Chasing the parasite. Our experience with Acanthamoeba keratitis.
Among microbial keratitis, Acanthamoeba keratitis is considered a relatively rare cause for corneal infection in India. Diagnosis of Acanthamoeba keratitis is both challenging and difficult. High index of clinical suspicion coupled with excellent microbiological support helped us detect a huge number of Acanthamoeba keratitis cases recently. Through this video, we try to share with the audience our experiences and observations while chasing this parasite capable of blinding many otherwise healthy individuals. Acanthamoebae are free-living organisms that can be found freely in the environment. Microtrauma to the cornea provides access to the organism to invade the cornea. For identifying Acanthamoebae, scrapings were taken from the active edge and base of corneal ulcers and examined under wet mounts with normal saline and or 10% potassium hydroxide. For isolation of this parasite, non-nutrient agar with E. coli overlay was used. This interesting amoeba captured our microbiologist's attention and she started documenting her observations. We invite the audience to look carefully at the acrobatics of this naughty and playful parasite in the following visuals. Look at these tiny specks and spots on the surface of the specimen. These may be mistaken for a normal pus cell. Sometimes these amoebae are so hidden within the specimen that they will come out only on continued exposure to the heat and the light of the examining microscope. This may resemble a march or a parade, with the amoebae trying to escape outside the specimen, forming channels. The spiky projections of acanthopodia on the surface of the Acanthamoebae are responsible for its motility and changes in shape. You will also see them tumbling and rolling over. Sometimes it just stops moving for a moment and makes the smear lifeless. This squirting movement is typical whenever you could see it. Cysts seen here are relatively immobile, round with double-layered wall. The smear here was prepared from hypopion aspirate taken from a young male diabetic patient who had to undergo therapeutic keratoplasty for a non-healing fungal keratitis. We could demonstrate Acanthamoeba in about 183 smears of corneal ulcer patients among the total of 802 microbiologically proven infective keratitis from December 2012 to August 2013. We had patients referred from 5 districts of Kerala and from Kanyakumari district. Youngest patient in our series was 6 years old and the oldest was 85 years. They belong to all socioeconomic strata, ranging from students, manual laborers to housewives and professionals. The ulcers range from small punctate or partial ring infiltrates to large corneal abscesses with hypopion and stromal necrosis as seen here. we treated these patients with a combination of reconstituted chlorhexidine 0.02% and neomycin. Polyhexamethylene biguanide 2% was added to this combination whenever the response was inadequate. 2/3 of our cases had coexisting fungal keratitis. Is this an outbreak, or is it just that we learn to detect this parasite more often? We are not yet sure. This graph here clearly shows a rising trend in incidence of Acanthamoeba keratitis. We decided to look beyond the ulcers to identify a specific predisposing factor for these infections. Contaminated water exposure has been cited in the literature as a major source for Acanthamoeba infections in the West. Majority of the patients in our series were using groundwater for domestic purposes. Frankly, none of them were following any water quality monitoring protocols. Many confessed that cleaning of their wells was not regularly practiced. Samples from water sources of these patients were collected and subjected to microscopy and culture and examined for the presence of free living amoebae. The report from State Public Health Laboratory shows a high coliform count, which is much above the standard acceptable levels for domestic use. We could demonstrate Acanthamoebae in samples from well water from patients' homes. Fortunately, so far we did not identify amoebic contamination from corporation water supply samples, though few of our patients were residing within the city limits. It is a scientifically proven fact that bacterial co-contamination of water with Acanthamoeba may facilitate the survival and growth of these amoeba, which will otherwise remain as dormant cysts. Contaminated water containing high coliform bacteria can act as a suitable medium for its growth. We would like to remind you here that E. coli are the same organism used to lay on top of non-nutrient agar culture plates to promote growth of Acanthamoebae from scrapings. The website of Kerala Groundwater Department is found to report that more than 70% of the wells in Thiruvananthapuram are contaminated with coliforms. Also, it reports that major rivers of Kerala, including Pamba and Karamana River, are highly polluted, more so during festive seasons. In the meantime, we also noticed a lot of media reports regarding water scarcity and usage of contaminated water for domestic purposes in various parts of Kerala. These reports and observations to a certain extent support our hypothesis linking contaminated water sources with recent higher incidence of Acanthamoeba keratitis. We continued our efforts to educate the patients and their families regarding the need for clean water habits and for regular quality monitoring of their water sources. We also issued a hazard alert report and submitted it to higher authorities in the Public Health Department, expecting some concrete action against this growing threat. To conclude, Kerala, once better known for its high health indices, is now more known for epidemics of viral fever and other infectious diseases. Our eyes too are victims to this deteriorating general health standards. Our journey with this parasite has just begun. We need to travel together far more distance to understand more about the clinical course, behavioral patterns, and seasonal variations of this mysterious parasitic disease.